Hey everyone, welcome back. Today we're going to look at the Pythagorean Theorem, and we're going to look at the proof of the Pythagorean Theorem. So a reminder what the theorem is. Let ABC be the length of the sides of a right-angled triangle, where C is the length of the hypotenuse. Then A squared plus B squared equals C squared. So let's dive right in. So let A and B be numbers, and we're going to consider the following. A square here that is a plus b by a plus b. So the area of this square is 1, 2, 3, 4. These four different shaded areas. The first area is a times a, so we call that a squared. The second area here is a times b. The third area is a times b. And then the fourth area is b times b, which is b squared. So AB plus AB is 2AB. So the area of this square here is a squared plus 2AB plus b squared. Now we're going to rewrite this square a little differently now. AB, and instead of going AB like this, we're going to alternate AB, 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 AB as such. And we're going to connect those 4 points like that. And what we did is created a square with 5 different areas. So we have the center, A1, A2, A3, A4, A5, like that. The area of A1 is C times C. It's a square here, so we get C squared. For the area of the second part right here, this is A times B divided by 2, right? This is the area of a triangle, so half AB. 3 is the same thing. A times B divided by 2. A times B divided by 2. A times B divided by 2. So we have C squared plus 4 half ABs, right? 1, 2, 3, 4. 4 half ABs. 4 divided by 2 is 2. So the area of this square here is C squared plus 2AB. Now these are the same areas. The areas are equal. So this area, A squared plus 2AB plus B squared, is equal to this area, C squared plus 2AB. 2AB on both sides, we can negate that. Negative 2AB on both sides, which leaves a squared plus b squared equals c squared. And that right there is the proof of our theorem.